I'm going to test this one now. I call this the thick bit because it's got thick laminates. I have two of these. This one is the thick bit. It's got 13 UF worth of caps in series from the grid to the primary. They're not in parallel, they're in series from the grid to the primary. This really boosts the output quite a bit. It makes more draw in the input, but it's a good gain comparing the output to the input. Okay, so now we'll look at how much it's putting out. It hums now. Anyways, here we go, 92.2. 92.2. That's how many volts are across a 111 ohm resistor. This is the amps. It's at 0.05 square divisions. So each of those square divisions is 0.05 amps. And I wrote down 24. Okay, so that's the amps. Now let's do both of them. Volts and amps. And it looks like a four spaces to the phase shift. Horizontal spaces. There's 5 of them within each square division. And I'd say it's 23 spaces, from for one AC cycle. And that's 360 degrees. So you divide 360 degrees by 23 and you get 15.65 degrees per space. Okay, I'm going to show you the math now. Okay, here's what I wrote down. The output's 92.2, but I wrote down 92. So it's 76.2 watts output, right around there. That's how many watts it produces from the secondaries of the transformer in series. So that's the output, 76. Input, I'll just tell you right now what it is. It's 45.6 watts in and 76.2 watts out. And if you're wondering how I got to that, first of all, I said it's 24 spaces peak to peak vertical, because when I did this before, that's what I had, and it's pretty much like that now. Anyways, 0.05 volt square divisions divided by 5, that's how many of those little spaces there are within one square division. So it's 0.01 volt per space. There's 24 of them. 24 times 0.01 volts is 20.24. Divided by 2 is 0.12 times 0.707 to make it RMS. Comes to 0.084, and I have a 0.1 current shunt. So there's what the amps is, 0.84 amps. And I know it's 120 volts AC coming in, it's the grid, times 0.84 is 100.8 volts amps. Phase angle, remember it was 23 for one AC cycle. So there's that, 360 degrees, and it's every one of those little spaces is 15.65, and there's 4 of them in the phase shift between current and voltage. And look, we get a phase shift of 62.6 degrees. And let's just say it's 63 degrees. And the power factor of that is 0.453. So we already figured out the volts amps is 100.8 volt amps. So there it is there, times 0.453 power factor, and you get 45.6 watts in, 76.2 watts out. I did 2 other tests today. This one's with a 13 UF cap in series. And all 3 tests are kind of about the same. Somewhere around 40 in and 70 out, 45 in, 75 out, something like that. So, okay. 3rd test of the day. Thanks for watching.